This lesson today is about sequences, and some of the things we'll be doing is talking about the different ways to write a sequence as well as the different types of sequences. So by definition, a sequence is an ordered set of numbers, which is the range of a function whose domain is the positive integers or a subset of the positive integers. If we're using the set of positive integers, the sequence is an infinite sequence. And if the domain is a subset of the positive integers, then it is a finite sequence. Terms are the members of the sequence, and the nth term corresponds to the positive integer n. So b sub 5 would be the fifth term. The sequence whose nth term is b sub n is denoted by b sub n in that braces notation. That would be the formula of the sequence. So finding the fourth and 10th term of the sequence means we could rewrite our formula as b sub n equals 3 to the n minus 1, and then plug in b sub 4 would be the fourth term, so 3 to the 4 minus 1, which would be 3 to the third, or 27, and b to the 10th would be 3 to the 10 minus 1, or 3 to the 9th, and that would be 19,683. Of course, you would plug that in your calculator to find that value. There are two ways to describe a sequence: the general term or the explicit formula. We give our sequence a formula, if that would be 3 to the n, and n would correspond to which term we want. So we would plug in the value for n and multiply it by 3. The second way that we can give you the first term and the relationship between each term and its successor is called a recursive or implicit definition, and that has two parts. And two parts of the recursive definition: the first term, so a sub 1 is the first term, and then we have a formula, and it's how we're going to find the next term. So a sub n would be equal to 3 times a sub n minus 1, which would be meaning that I would take the term ahead of it times 3. I could also write it this way: a sub n plus 1 equals 3 times a sub n. That's an equivalent formula which would also generate the recursive. So it says find the first four terms of the recursive formula. So we start with a sub 1 equals 2, and then we're going to say to find a sub 2, we're going to take 2/3 times the previous one, which is a 2, and that would be 4/3. And then a sub 3 would be 2/3 times the previous one there, which would be 4/3, and that would give us 8/3. And then, 8/9. And then a to the 4th would be 2/3 times 8/9, which would be 16/27. So the first four terms then would be 2, 4/3, 8/9, and 16/27. So basically what you're doing is taking the one before it and applying it into the formula. There are two types of sequences that we're going to look at. We're looking at arithmetic sequences, and looking at our formula. We would say that a sub 1 is our first term, n is the number of terms, and d is the common difference, And this is where we are adding term to term, and here we are multiplying term to term. And so in our first one, we would look to see what's happening here. As you can see, what's going on is that we're adding -9 each time. So the common difference, so this is an arithmetic sequence. And to find the general term, we start with the formula. A sub n equals a sub 1 plus n minus 1 times d. And so a sub n, our first term was 8. We don't know how many there are, and the common difference is -9. And then we are going to distribute and combine like terms, and simplifying that, we would get -9n plus 17. And that would be our general form. For our recursive definition, we would start with our first term. That would be an 8. So a sub 1 is an 8. And then to get the next term, basically to go from term to term, we're going to take the one previous and we're going to subtract 9. And that would be our recursive definition. And then finding find a formula for the 20th term. You could use either one. We're going to use the general term because it gives it to us by plugging in what we want. And I want to find the 20th term. So -9 times 20 plus 17. And that would give us -163. So that's finding that term using our explicit formula. Keep in mind, if you use the recursive, if I wanted the 15th term, I couldn't find 15 unless I knew 14. I couldn't find 14 unless I knew 13. And it becomes quite a daunting task, if nothing else, to come up with that particular value. So explicit term is probably best. And then here's our last example. Today we're going to find an explicit definition. So looking at the sequence, going from each term, we're multiplying by 2. So this one is geometric. And so we're going to use the general formula for geometric, which is a sub n equals a sub 1 times r to the n minus 1. And a sub n, our first term is 3 times, and then r, our common ratio, was a 2 raised to the n minus 1. And then what we will do is come down here and finish it. So 3 times, and now we'll use our exponent rules. And 2 to the -1 is a half. So that'll give us 3/2 times 2 to the n. And this would be our general form, or our explicit formula. In terms of the recursive, our first term, a sub 1, would be 3. And our formula to find that next term, we would be taking 2 times the one ahead of it. So more specifically, if I look at my sequence here, to go from 3 to 6, I'd multiply by 2, I'd multiply 6 by 2 to get 12, etc., etc. So that comes up with the recursive. And then to find the 20th term, a sub 20 would be 3/2 times 2 to the 20th. And that gives us 7, 2. So, and that would be our 20th term. And then your homework will follow with the worksheet over 11.1.